Well, hello everyone. I'm going to be giving this introductory talk. Mathieu Roy has done most of the work in preparing the talk, so he is available online and he'll be able to answer your questions at the end of it. As you all know, the term has not been defined. This is not attempting to define DSI. What it's attempting to do is highlight that the scope of this session will be rather narrow, focusing on nucleotide sequence data. And it's important to note that even within that very narrow scope, there are many different forms that nucleotide sequence data can take. Getting accurate, complete sequence data on whole genomes, despite recent developments in technologies, is still a really expensive and time-consuming exercise. So there are very few genomes that have been fully sequenced in that sort of way. The vast majority of the cases, we had to take some sort of compromise. We either accept low quality sequencing data, or we go for sequencing just small parts of a genome, or especially in the case of crop improvement, we do away with sequence data altogether, create genetic markers and go for genotyping. And we don't necessarily, depending on the genetic marker, we don't even necessarily know the precise sequence differences between different genotypes of plants. We've identified 4 categories of genetic resources. So in situ genetic resources at the bottom, then at the left, the genetic resources conserved ex situ, and then genetic resources being used ex situ for research and for breeding. And the point of this is just to show that different kinds of DSI are used for these different groups of genetic resources, because the cost-benefit analysis is different for the different use cases. We are seeing some general trends both within the CGIAR and outside CGIAR. Recently, in the past few years, we're increasingly seeing for many crops high quality sequencing of multiple whole genomes for each crop, which we use to create a so-called pangenome, which is a virtual entity created by combining lots of genomes that together represent the full or large proportion of the genetic diversity within that crop. And that creates a whole lot more value than any single whole genome. And that's quite difficult for benefit sharing, because what you're getting, the value you're getting out there comes from combining genetic resources from many countries. It doesn't really make sense to attribute value to any one of those countries. It's that the whole is greater than the sum of the parts. And increasingly, we're relying on digital catalogues of genetic diversity to make our decisions on conservation and use. And we're seeing increased use of DSI for crop improvement, especially with the new breeding technologies such as genomic and selection and gene editing. And open data and capacity building is really core for all of this. It's increasing in importance. So we're seeing now, just looking at the ex situ material conserved in gene banks, there's a very large percentage of the materials in the CGIAR have already been either resequenced or genotyped. And in some cases, a large proportion of that is, well, in some cases, the majority of that is available on public databases. The result is a multitude of databases. To put all these data into a single database, it would be an absolute minefield. The only way to go ahead with this has been to take it one step at a time, take one particular set of data, and for each particular genome, type of genome, for each community of users, for each category of use, we find you can more easily develop a highly specialized, if small, database for that community. So we see some multi-species databases here in the big red circle, but in most cases, you find it doesn't make sense to integrate combined data across crops. a lot of the database ecosystem circles around a separate set of databases for each crop. So here, just an example, there is our 4 DSI databases maintained by CGIAR centers. And again, the point is here, having 4 separate databases has allowed each center to produce a specialized product that works for its own community, for the types of genome that it works with, and for the purposes of their work. It just doesn't make sense to divert scarce resources into trying to combine these into a single database. So I hope we won't hear too much more about establishing a single database for all DSI under the CBD. It's interesting that the plant treaty has faced similar issues where they've wanted to have at least access to, if not control of, data relating to plant genetic resources for food and agriculture. And they've taken the interesting and I think very pragmatic step of allowing the use of digital object identifiers to identify material as well as data. And through that approach, they are able to get cross database queries. They're able to keep an eye on what they need to keep an eye on without establishing a completely new database system. That might be something that's worth the CBD might want to look into. It's core to our mission that we had to make data available, particularly to our partners in the developing countries. In general, we follow standard academic practices on data sharing. So the actual sequence data are deposited in a database of the International Nucleotide Sequence Database collaboration. And in general, access to the institutional repositories and our scientific databases is open and free. And we follow the Toronto Statement from 2009, which allows us to share data pre-publication, which is very important for the high rate of progress in these areas. In general, the specialized portals maintained by the CGIAR centers usually don't require logging, but they do require knowledge and attribution. And some also include IPR-related restrictions with respect to data. One center does require login and click-wrap license agreement for non-exclusive, non-transferable use of genetic data, subject to conditions such as not claiming IPRs over the data, but it depends on the center. Another core component of what we do is capacity building. For the developing countries, it's becoming an increasingly important part of what we do. It was pleasant to have this recognized by the governing body of the Plant Treaty last year. They welcome and acknowledge the technical assistance undertaken by the CGIAR centers to reduce the existing gap on capacity regarding generation, access to and use of DSI/GSD, which is another term that they use, and recommends that this work be continued and strengthened. We would be continuing and strengthening it anyway, but it's nice to have it recognized by a governing body. This is just a highlight, but DSI is being used in many different ways to enhance conservation and the availability of genetic resources to users. I'm not going to go into more detail because the details of this is going to be the subject of the next presentation. And similarly, we use DSI heavily for crop improvement, but again, I'm not going to go into details on this because that's a subject to the presentation after that. So without further ado, I will stop here, say thank you and pass straight on to Paula Reyes, who will give the presentation on the use of DSI for conservation.
Thank you very much. My name is Paula Reyes. I work for the Colombian Corporation for Agricultural Research, AgroSavia, and I'm going to give you this presentation on how we're using DSI to improve agrobiodiversity conservation, working towards a coordinated regional approach. Next. So at AgroSavia, we manage the Colombian National Vegetal Germplasm Bank. We conserve 275 species, and here in the figure I present, each circle represents a different species. and the radius represents the number of accessions that we are conserving. The accessions that we conserve have been collected since 1940, and an important part of the bank was collected before the 90s. Next. Here, this is the first part where we're using DSI. At our bank, we're focused on conservation, and it is crucial to understand exactly what we are conserving. And the bank has a strategy to characterize the genetic diversity of the accessions conserved at the bank. But first, to study the genetic diversity, it is important to understand the extent of knowledge we can gain based on the information available. And first, the availability of our reference genome, it is very important for us. Here in the figure, I present you the availability of reference genome by regions of origin for the species that we conserve at the bank. In red is there are the gaps, and I highlight two regions, the Andes and tropical South America, where Colombia is located, that have the biggest part, the largest gaps. So 50% of the conserved species lack a reference genome. So studying genetic, so we have benefited a lot from the reference genomes available. The availability of a reference genome, or pangenome nowadays, enables not only to study the genetic diversity in a greater detail, but also finding novel genes. Since we have half our bank doesn't have a reference genome, we develop a strategy to study the genetic diversity without a reference genome. But so we can do that, but we don't not achieve the same results, of course. Next. And second part where we're using DSI, we're comparing the accessions that we conserve at the bank by using DSI. This is important because species do not respect geopolitical boundaries. And here I present you an example of how we study avocado accessions. So in this figure, I present a PCA based on molecular data. And there are three races known for avocado: the Mexican, that is in yellow, Guatemalan in green, and the West Indies in blue. So we use DSI from the NCBI that were genotyped using the same technique that we used to genotype our accessions. And this helped us because this the DSI had reference material for the known races. So this helped us to classify our material into these three races, but we were also able to find a novel group. This red group was composed only from materials from Colombia. So this is important for us. So, next. And so I have been involved in the community of practice of Latin America and the Caribbean gene banks. This is coordinated by Monica Carvajal and Carolina Sansaloni from CIAT and CIMIT respectively. This community makes a lot of sense. Here in the upper part of the slide, I present you the mega diverse countries. And there are 5 mega diverse countries in the Latin America and the Caribbean. So it is very nice to have a community like this. In this community, there are 14 countries involved, 21 institutions. We have had 7 meetings, 2 in person, and we are sharing data and doing the analysis in teams. We received an invitation to genotype data, genotype accessions for specific crops, and AgroSavia sent samples for potato and bean accessions. Next. So the benefits, we are sharing DSI and metadata, and we are doing the analysis by crop and not by institution. Here I present the bean example. These are all the institutions that have been involved in the analysis of the bean. And in this PCA, we see data from multiple institutions. So by this, it is possible to compare the genetic diversity to other collections and understanding the importance of each crop genetic diversity, not only limited to the accessions conserved by institution. We are sharing data, experiences, and tools to analyze as well. This community presents the benefits of DSI sharing to all the participating institutions. Not all the institutions were able to send data to genotype, samples to genotype, due to regulations or lack of capacities. However, these institutions have been participating in the analysis and seeing the benefits of DSI and teamwork. Next. So the benefits of using DSI for conservation: see conservation as a regional effort and not depending on determined institutions. We are sharing DSI to pursue the analysis of crop genetic diversity at a regional scale in a mega diverse region. We also could be able to identify common accessions that could serve as backups. A big part of our bank doesn't have a backup, so identify backups in other banks, it's an opportunity for us. And this also opens an opportunity to create a regional core collection that could benefit from multiple characterizations. At last, it could also help to establish connections between core collections. For example, SIP has its potato core collection genotype, and we sent our core collection to be genotyped so we could compare both. And at last, the sharing DSI could benefit also identifying accessions that are not conserved in the banks, for example, in situ conservation. And here ends my presentation. Thank you very much.
Okay, thank you, Paula. So at this stage, I'll swap places with Carolina.
You're ready.
I'll make sure you're plugged in.
Okay. Well, hello, everyone. My name is Carolina Sansaloni. I'm the Gene Bank curator at CIMMYT. We hold two of the largest collection of maize and wheat. And I will talk today about how using DSI for crop improvement. So it's very well known that during the domestication process, selection of land races, and even modern plant breeding, the crop diversity of many crops has been reduced drastically. One very good example of breeding is the land races of pre-Green Revolution, and in the end, an elite varieties post-Green Revolution. So this is a very nice example of our Norman Borlaug legacy. But during this process, many genes are left behind, not because they are not good or bad, because they focus in one trait. In the previous example was plant height. So many genes during this process are left behind. And one example of this is a study that we did after genotyping almost the entire collection. In this case, we are looking at chromosome 3A. So you can see all these dots are molecular markers across the chromosome 3A. And we position one very important gene for breeding. And on the top, you can see the chromosome of a landrace, and on the bottom, the chromosome of an elite varieties. In this question mark, there are some missing allele from this gene that are missing in the elite varieties. Means that there has been lost in this breeding process. So how we rescue all these genes or allele of genes that are missing in the breeding program? So it's not an easy process, and most of you may know, it's like your kid asking for a kitty and you bring home a tiger. So it's not very easy as a mom or as a breeder. I don't want a tiger in my house. So what breeders or pre-breeders do is transform this tiger in something similar to a cat. It's not a nice Siamese, but it looks more a cat. So we can split in pre-breeding program and finally breeding program. So some real examples you can see in one of the picture, wheat. So a very wild or land races. We have in the gene bank land races, but also quite crop-wide relatives, so very diverse. And next, the very pretty homogeneous elite varieties. The same in maize, at very high land races, sometimes more than 3 meters, and again, more homogeneous elite varieties. So definitely DSI can assist in the development of new products more rapidly, more efficiently, and more effectively by selecting directly on genotype instead of looking at the resulting phenotypes. How we can do and how we can speed the process? Well, there are several methodologies that can be applied. One or most used is the genome-wide association study, in which basically we characterize genetically the accession. We look at the DNA level, we generate DSI, plus we evaluate in the field. We have a lot of phenotypic data. The combination of both, we can generate this beautiful and very famous Manhattan plot in which we can identify genomic region controlling different traits. So molecular markers associated with different traits of interest. But it has one issue. Most of the time, the generation of phenotypic data is very expensive, time-consuming, and we have interaction with the environment. So we can avoid this by a more new approach, which is environmental genome-wide analysis, in which we use exactly the same DSI, exactly the same genetic information, but we combine with climatic data. Climatic data is basically free. And we use this climatic data as a phenotypic information. So the combination of both, again, we can generate Manhattan plot and identify molecular marker associated with environmental traits. When I say environmental trait, as an example, heat, drought, soil salinity, and others. Today, we have 7 to 8% of variation associated with potential adoption of drought and heat in maize. And 12 to 17% are only and exclusively in land races. So there is a lot of potential to bring new genetic variation into the breeding program. So by doing this analysis, we identify novel variation from different countries and different origins. And they are already in pre-breeding programs. So we are transforming the tiger now. Another example is genomic selection. Basically, you have a big population, a big number of samples, but you only phenotype a subset, a small portion of this population. And this becomes your training population. So you genotype the entire collection, you phenotype a small portion, you can develop a predictive model and predict the phenotype of the entire collection. So this is a nice approach, not only reduce the cost, of course, but I think more importantly, you speed the breeding process significantly. And to summarize, I feel that before DSI was really challenging for breeders to go into a gene bank and identify useful genetic variation. It was very, very challenging. Imagine I manage 150,000 wheat accession at CIMMYT Gene Bank. It's really challenging for breeders to find something useful. But after DSI, the work is much easier. We can focus and be more efficient in selecting what is useful for breeding program. So DSI is key to unlocking genetic potential of crops, enable sustainable agriculture that can nourish future generation and ensure food security in a changing world. Thank you.
Thank you, Carolina. So now we move on to some more speculative ideas about how DSI is changing how we use genetic resources in agricultural research and development, and consider their implications for benefit sharing. So I think I need to start by just stepping back a bit and thinking how it used to be. It's not explicitly stated in the convention, but the benefit sharing regimes that have been developed implicitly assume that we have in vivo replication of the units of heredity. So you take a mother plant, you take a father plant, and if you produce enough offspring from those two parents, you have a good chance of finding offspring that combines the best of both parents, and you end up with a product that's commercially valuable. And in this case, it makes a whole lot of sense that benefit sharing is based on the incorporation of genetic material from your original genetic resources into the final product. That's how the plant treaty works, as well as the convention. But DSI changes how that works, and we have identified 3 different ways that are really critical for thinking about access and benefit sharing. The first is that DSI delinks the use of genetic resources for research from their use for development. Second is that DSI-related technologies enable in vitro and in silico replication of the units of heredity. And the third is that DSI enables discovery of unrelated genetic resources containing the same sequences. I should briefly go through each of these one by one. As you've heard from the previous 2 talks, now the vast majority of genetic resources and associated information are used in the research phase to create the knowledge and tools that you need to develop products. Quite a small proportion of the genetic resources may go into those final products because you've put so much effort into identifying, creating the knowledge that you require to do that. So we've already talked about reference genomes being enormously valuable, a very small number of genomes that contribute disproportionately to our knowledge of crop diversity, and genome-wide association studies where you take hundreds or potentially thousands of samples from different countries. And if you base your benefit sharing just on that small proportion of the gene pool that goes into making a commercial product, well, that's really not fair or equitable, doesn't recognize the contribution of all those countries that have contributed their genetic resources on which you've based your knowledge. Even in the very simple situation, if you can imagine one genetic resource is collected from some country and converted directly into a product, if you're using DSI to discover and create that product, you will be relying on information derived from many other genetic resources. And it's not fair, even in that very simple case, to say that one country should be the beneficiary of all benefit sharing. The second is that DSI-related technologies enable in vitro and in silico replication of units of heredity. So here we're talking about, on the left, the classic in vivo replication. With genetic modification and gene editing, we can get the DNA in vitro, replicate it there, modify it there, and then put it back into a product, which is a genetic resource that becomes commercially valuable. With synthetic biology, we can go one step further and replicate the units of heredity on the database. And through a DNA foundry, we can go back to real DNA and incorporate that DNA into a normal product. I'm not particularly concerned about this, as long as you don't say the convention and the treaty disregard information, because neither of those instruments defines units of heredity, nor do they define or restrict how units of heredity can be replicated. And so there's no reason why this in vitro and in silico replication of units of heredity shouldn't be included in your ABS regime. So it seems quite rational to extend ABS concepts to include the GM and gene editing and synthetic biology. The third is that DSI enables discovery of unrelated genetic resources containing the same sequences. And I think it's quite a few years now since this was recognized as a really serious loophole in both instruments, that you can use materials from the multilateral system of the plant treaty or any other ABS regime, whether it's under Nagoya or whatever, in your research phase, And through your research, you can discover a desirable sequence that you want to incorporate into a product. And then you go off and look for a different genetic resource, which is not regulated, get the sequence out of that and put that into your product, and you've bypassed all benefit sharing provisions associated with the material that you did the research on. And that's clearly not fair, and it's not equitable, and it's entirely appropriate that your benefit sharing regime should take into account that unrelated material may have just as valuable sequencing as material that's under the ABS regime. So what we conclude for the ABS implications are that benefit sharing in the era of DSI can only be fair and equitable if it delinks payment obligations from incorporation of DNA sequences into final products, and if it recognizes, reflects, and rewards the value contributed by DSI through the upstream research, not just the incorporation of genetic resources into products. I shall stop there and we'll move on to Gustavo to take this a little bit further in considering the options for future-proof DSI, benefit sharing and availability. So if I do the same again and hand over to you, Gustavo, are you there?
Hello, can you hear me?
Yes, we can hear you well.
Oh, thank you so much. All right, so what I'm going to present you is some options to future-proof DSI, benefit sharing, and availability. I'm going to show you a brief history or a brief picture of the inner workings of how we treat the genetic resources and access to it, and the lessons that we have learned and how we can apply those lessons into the mechanisms. So next slide, please. All right, so in Colombia, the sole national authority that grants access to genetic resources is the Ministry of the Environment. To regulate it, we use the legal framework provided by the Andean Decision 391, which is our equivalent to Nagoya, and is based on the principles of the CBD. Access is granted via contracts with clear terms of access to the genetic resource between the party and the nation. Party being whoever wants to access those resources. It could be a person, an organization, university, etc. Access is, if that access is related with indigenous peoples and their traditional knowledge, there is an additional step where the party is obligated to negotiate the specifics of that access with the indigenous people. And with that authorization, we continue the process with the party. All these steps are depending on a clear definition of what a genetic resource is, access to it, and the contract. It's a little bit complex, but it is legally solid and tailored around the terms of access and the terms of the distribution of benefits. Over the years, the Colombian government legislated to streamline that process and include clear exceptions for activities that are related to research and government use in order to facilitate them and encourage them. The genetic resource is a physical resource. When you access it and when you study it, you get the DSI. We aim to ensure that by the time the information is uploaded to a public database, all parties are aware of the implication. And this is where the paradigm of sharing of benefits begins to change, because digital information is easy to copy and easy to share. And technology keeps advancing. So the principle of access and benefit sharing have to be different, but they can learn from years of experience. Specifically, we can take a note from those 6 mechanisms regarding the traceability of the benefits generated and received, the legal certainty, the exceptions of research, and to respect the rights of the IPLCs over the traditional knowledge. Next slide, please. The multilateral mechanism that is currently in discussion works from that relationship between those that provide the DSI and those who use it, and the global fund that holds the benefits collected from the use of DSI. Decision 15.9 does a great job of listing the requirements of the mechanism, and the coming days parties will work out a decision. I mean, work out a recommendation for COP16 on the on the inner workings of the mechanism. There is much to discuss regarding, well, everything, the specifics of the mechanism, but we consider that it is important that the mechanism supports biodiversity conservation efforts in the global south, that it takes into account the needs of the IPLC, that it doesn't hinder research, and that it is conscious of how DSI is used. The fund will not solve all problems, but it will help with the goals and targets of the commitment trial, and it's going to be, I mean, it should be in line with the objectives of the CBD and help with the needs of the IPLC. As for the trigger, as we know, DSI is used in a number of ways. So we want something that is simple and broad so as to mitigate as much as possible that potential impact to providers and users of DSI. The trigger options that are currently in consideration in the document 2/2 and, well, in the conference in the CRP have merit and need to be studied in detail. The one with the highly dependent sectors could be potentially much more easier than having to identify individual products or to set up a global fee. But I mean, a lot needs to be discussed regarding all of them. But how does this translate with the reality of how DSI is used? Next slide, please. There are multiple sectors that use DSI. Academia, those DSI-dependent sectors that were mentioned in one of the triggers that tend to be a little bit more commercial in their use, and anything related with AI that sort of shatters that definition of use, and governments, that a sector that is not often thought of as one that has heavy use of DSI, but due to national and international regulation, a government has to, for example, regulate agricultural products, take measures toward keeping of the agricultural health, food safety, inspection, surveillance, and sanitary control of products and other activities related with living modified organisms and whatever synthetic biology throws into the mix. The list just goes on and on and on, and all parties do this in one way or another. The most common way DSI is used is that you look for a gene or sequence on a database and you take that information and use it in any of the aforementioned sectors. But nature is surprisingly conservative. Everything is everywhere and nature selects, and that gene might be found in a number of organisms for multiple origins. That DSI might fall within the scope of different mechanisms. Ours in the CBD, PB&J, FAO, and whatever the future brings. All that without mentioning that most biotechnology applications require access to public and private DSI from public and private databases in different proportions. If the obligation of each and every one of these mechanisms is incompatible with each other, then that will increase the financial and administrative burden, and it will just increase the cost of participating in the mechanism, and that relationship between the user and the provider will be affected in ways that are hard to measure, not to mention the risk of double payments or triple payments. If the mechanism is too complex, then we open up the market for tools to avoid that much. Next slide, please. Now, to future-proof the mechanism, we need to keep an eye on the rear-view mirror and learn from those lessons from the existing benefit-sharing mechanisms. The national legislation of every party is different, and it dictates the compatibility of other mechanisms. The possible implication that this one will have with national legislation, with the national legislation needs discussion, because while there isn't much regulation that handles benefit sharing from the use of DSI directly, that doesn't mean that there isn't legislation on the activities related to the creation of DSI and to the access of that information. We need to leave room for education, agriculture, health, and understand the needs of providers and users. Much of that information was uploaded with a purpose in mind. And we always hear about the INSDC and the 3 largest databases, but not a lot about the other databases that uses information from those 3, not to mention all the tools and services that are related to those databases. It is not as simple as just creating one big database or creating an account for each and every one of those databases in order to access the entire wealth of information. Another thing that we can learn is that to avoid that complicated language. And what do I mean by complicated language? Is that we can discuss about the exact definition about DSI, about the definition about a product that uses DSI really is, and we might find an answer, but then we start going down the rabbit hole of what is and what isn't, and that might be easier said than done. What we need is umbrellas, broad nets with tight, really small holes. The idea is to have something that is easy to implement and is to coexist with existing regulation and treaties. So the more general the mechanism is, the broader the base of contributors to the mechanism, the more easier it will be to reach an agreement around. And lastly, the mechanism needs to be under constant review. And the factors considered by the co-chairs are a good start, as the landscape of DSI can and will change and will impact the efficacy of the mechanism. Thank you.
Thank you, Gustavo. So now we'll move on to bring Michael back to the table to his talk.
Thank you very much. I assure you there will be a moment where we take questions and answer questions. It's just given the technological difficulties we're having, we wanted to get through our presentations first. So first, before I reflect and look at more detail at the non-paper and how that links to what it is that we're saying today, I just want to refer again to these sort of three things that Rory mentioned about how DSI is changing the way we use genetic resources. DSI delinks the use of genetic resources from research and from its use in development. Upstream use and analysis through DSI of a huge range of genetic materials. It takes place without that material and that information finding its way in final products. You saw the GWAS examples given by Carolina. There were 17,000 different accessions used in one and 20-something thousand used before, and that association of DSI with phenotypic information to discover traits. Without that step, you're not going to have a final product that includes the benefits of that research. And to leave that out makes no sense. Why would people put material in if they're left out of the benefit sharing formula? Why would they contribute it in these mechanisms whereby you pool information about material in the form of DSI for precisely this kind of research? DSI technologies enable in vitro and in silico replication and enables the discovery of unrelated genetic resources. And that leads to our conclusion that benefit sharing in this era is fair and equitable if it delinks payments of obligations from incorporation of DSI DNA sequences in final products. So you've seen those slides before, but sometimes repetition of the same message is useful for getting a message home. So what could delinked benefit sharing look like? We talk about it all the time, and I think this community is maturing extraordinarily fast in terms of thinking through what those options are. But one option is, of course, that aggregate level payments on whole portfolios of products would be made by users, defined quite broadly, whether those products were developed using Access DSI or not. Another is that contributions from users would be based on a percentage of additional fees for cloud-based services, which we've heard from Paul Oldham over time. A third is that there would be contributions from DSI service providers, selling reagents and conducting sequencing and developing analyses, which they then share on a fee-for-service basis, which we pay for sometimes. So to move from that to reflections on the non-paper, we have these three options in front of us, and on option A, we think does not conform to this delinking of benefit sharing from the products. I've heard it said that one could read that the products and services placed on the market could be addressed by predefining what are the products. So you define a portfolio of products, and then you don't have to track and trace into each one. But if you do that, then really you're in option A. Option B, which is the sector. So if you're looking at a sector, that makes sense. We certainly have a preference for the sectoral approach, in as much as it identifies upfront the issues that were flagged by our presenters and addresses upfront the risk of avoidance, which is, of course, what plagues these other systems where you've got tracking and tracing involved, and the hair splitting that gets introduced and incentivized when it's possible to get around. Taking a sector-specific approach gets rid of a lot of that problem. It doesn't get rid of it entirely. You can still imagine there's a moment at which some company could say, well, that's not my sector. I'm not part of that sector. And it was for that reason that, in fact, we published a paper some months ago. I think some of the co-authors in the room, Margot Bagley is here. I don't know if Amber is here, and Marcus Weiss, wherein we suggested that, in fact, that one should look for aggregate levels of benefit that would address this risk up front. And GDP might be a good way to start in that case. You know, we said sectors as a plan B if contracting parties weren't just interested or not willing to look at GDP as the proxy for identifying how much of payments should be made by a contracting party, look at sectors. But sectors is a slightly more dangerous thing than GDP, of course, and then leaving it to countries, of course, to find out from whom they would seek to recover the money based on a GDP calculation. So nonetheless, we think option B is great. Having option C introduced makes perfect sense. It was, of course, it's the Africa Group proposal. It was the Africa Group that kind of forced us all collectively to look at this delinking seriously. My reading of the room and my reading of the situation is that there's been less support for that maybe than B, because B involves a smaller number of players. It's easier to track and trace a finite number of companies than to try to create a system whereby all retail people buying at the retail level would be making payments. We think it's paragraph 5, of course, and the role that's anticipated for contracting parties to come in and put measures in place to require those payments from companies, commercializers in their jurisdiction is absolutely essential. And we're really quite happy to see this included in the text, and a little bit surprised. It felt 2 years ago like that was not a possibility. And so we thank the international community for moving ahead on that regard. We do think, however, that more work is going to be necessary to ensure that each contracting party puts in place measures that are similar enough so that you address up front, again, this possibility of setting up a market for avoidance. So, I think we have to make it clearly identified, and it should be common across all contract parties, who's going to pay, how much they're going to pay, maybe how often. Those are sort of the de minimis common elements that would have to be included to avoid avoidance. There may be others, and that would be something that we can learn over time. And that's one of the nice things about what's being anticipated now, is that there is this 2-year review, looking at what's working, what's not working, and being able to tweak the system. So if we get some of these things not perfect, we can come back. Yeah, right. This is the problem with interactive. With respect to reflections on the triggers, we just had a long discussion about that, so I won't say more other than to note again, as we did in the plenary. This is an opportunity to move the needle. Right now, what this says is it's a good thing to share non-monetary benefits. That's fine. We all know it's happening on a decentralized basis. Is there something we can add right now to some obligation or some encouragement to be more systematic about it? Creating incentives for organizations such as our own to do still better at generating and sharing non-monetary benefits and reporting on it. And I'll just leave it at that for now. Entities operating public databases on DSI are encouraged to require, where possible, fair and care principles. Again, that's fine. It's encouraged. It's not prescriptive. But I think it's important to note that when we talk about open access, we're actually talking about something that's less restrictive often than can be described as fair. We have some databases that are certainly fair, but they're not entirely open access. And I think we should be trying to look for open access where we can, in terms of providing a policy basis for expanding the use and taking advantage of DSI. And mutually supportiveness with other instruments. What does that mean? Well, what's said here doesn't mean much other than it's a principle. It's nice, but I think. And this is a cue up really for what Alvaro is going to talk about. But from our point of view, I think what's really important is that whatever benefit sharing triggers are developed and whatever systems are put in place, the global data set that should be available through the multilateral mechanism isn't fractured and subjected to sort of notional or actualized jurisdictional divides between the current instruments, so that DSI derived from genetic resources that would be under the CBD would somehow have a slightly different set of rules than DSI derived from materials that would otherwise be under the treaty. There's no need to approach it that way. You're going to have benefit sharing under all of them that could be recognized and allow you to the entire DSI data set without it being differentiated. Now, there's one caveat when I say that. That doesn't mean all DSI everywhere in the world. We know that there's DSI held by private organizations. There's DSI that's highly sensitive for indigenous and local peoples. We're not talking about that. But what you would expect to be out there in public databases should not be broken up, fragmented as a result of the way we approach the implementation of different international instruments. And I'll leave it at that and turn to Alvaro. Actually, I think even though you don't have a microphone, you don't have a PowerPoint, or if you do, you still have to sit here because the others won't hear you outside.
Okay, so well, thanks to the CEAR for inviting us to be part of this side event. I think to start from the question from Michael, I'm going to try to basically respond this idea of encouraging mutual supportiveness. I think that's clearly a matter for the parties to discuss. It's not for the Secretariat, but I think give some information that I hope would enable negotiators in this forum to understand a little bit our own context and where we're going. At the outset, I would say that while there are negotiations related to DSI in the context of the treaty, the question raised by Michael about data governance and how fragmenting the data landscape, DSI landscape as a concern, there's very little within the negotiations of the treaty right now relating to data governance. And the treaty has, for over 20 years, basically promoted a system of facilitated access to plant genetic resources for plant innovation and science. So I would tend to see that I don't think the treaty governing body would be the one taking any decision that would basically promote this fragmentation of the DSI landscape. I just don't see that as one of the main objectives of the negotiators within the treaty. There's a lot of respect for the questions related to access to information as a mechanism of benefit sharing. So that is not one of the priorities of the negotiations within the treaty currently. It should also be highlighted that the agricultural sector is one of the main generators of DSI, and that has implications not only for the agricultural sector, but for other sectors that are going to be using that information in the future, and that would potentially contribute to the mechanism being set up by the CBD, which I think it's important for the treaty in the treaty context, because that was one of the questions that really made it difficult in 2019 to finalize an agreement on the treaty's enhancement. So what is the treaty trying to do right now? Just some background. I think many of you would know But I think it's important to try to understand it so that we can have a bit of a more practical discussion on how to enhance mutual supportiveness. So the treaty is trying to improve its multilateral system on access and benefit sharing. The main idea is to expand the network of gene banks around the world that share material, plant genetic material that is essential for food security, and to expand benefit sharing from the use of this exchange, basically. This is important for all of our members, as we all depend in the same plants to feed our citizens. So, and we need to move forward by also using a wider variety of plants for nutritional and sustainable food systems. So that's the development goal that basically we are trying to do through the treaty's enhancement. The treaty has 3 hotspots in that negotiation. First is to establish new arrangements for benefit sharing payment structures and terms, and in particular the development of a subscription system for users of the multilateral system, the expansion of the number of crops that are shared through the MLS, including many important for global nutrition, and that would be done through an amendment of Annex 1 of the treaty, and the integration of DSI into the enhancement of the multilateral system. So this is important to bear in mind in this context. In the following terms, the treaty considers that expanding facilitated access to physical material of plant genetic resources is essential for sustainable development and innovation in agriculture. So the treaty is not trying to develop a standalone DSI-specific benefit sharing mechanism. It's just trying to integrate DSI in the development of an approach of benefit sharing for plant genetic resources for food and agriculture. This is important also because innovation in plant breeding and agricultural plant science, open science, is not dependent only on the availability of DSI. We hear now that this is a very, very, very well articulated principle within these negotiations, but plant innovation and plant breeding is going to require not only DSI. It seems like the availability of public databases of terabytes of DSI is now the new green gold, but we've seen in the past that basically plant innovation, plant breeding is dependent on a multiple number of resources, including, of course, it's going to be including DSI, but it's also going to include genetic resources as such, and of course, other forms of data that would include evaluation data and other forms of data that I think my colleagues in the CAR have explained before me. So the treaty is trying to deal with DSI from PGRFA in the context of the mechanisms that the treaty has developed over 20 years. So there are a number of tools that the treaty has in terms of the standard material transfer agreement. It has a fund to receive the benefit sharing arising from the multilateral system. It has a global information system. It has tools of implementation such as the use of DOIs that Ruri has stated. It has the agreement with the international research centers. So it has a panoply of tools that it's using, and it's trying to enhance and modernize to deal with DSI. It's different with the approach being taken in the CBD, that it's trying to create a new mechanism almost from scratch. So these are some of the questions that I think need to be taken into account in understanding how to enhance mutual supportiveness between the treaty and the CBD in this new era of benefit sharing arising from DSI. It's very difficult to go into what concrete measures could be taken to ensure mutual supportiveness or complementarity. I think that's clearly a matter for the parties. I thought the discussions this morning were very productive, and there are many ideas in the table, and a number of the principles stated this morning coincide or have been echoed in the negotiation of the treaty. So I think articulating these principles in decisions and resolutions of both bodies should be a minimum first step. I think it's also going to be important to be pragmatic if we want to finalize both the enhancement of the MLS and the definition of the mechanism here at the CBD, and understand that there would be review processes on both forums. So there would be possibilities of understanding how different approaches being taken have worked. There's possibilities of using certain analysis that we are developing in the context of the treaty, also in the context of the development of the mechanism. So, I mean, I think that might be useful because some of the data arising from the studies related to the plant breeding sector have not been very well welcomed by many of the stakeholders within the treaty. And I think maybe we have more knowledge on how the plant breeding sector works. So there are also ways in which in the next intersessional period there could be more complementarity in that side also. The co-chairs of the two working groups have been in discussions. So I think the cooperation between secretariats and at least the contacts between the coaches are also another way in which we are trying to ensure complementarity. So these are some of the ideas that are on the table, very pragmatic on how to ensure complementarity. I think there are many questions, especially from many of the users, on complementarity, on avoidance of double payments. This will need to be sorted out, but we need to understand better also how each mechanism is developed a little bit to really understand where the uncertainties and will be. So that's my own reflection. Thanks so much.
Okay, thank you very much, Alvaro. We have 15 minutes, unprecedented, for questions and answers. Wow, and I see one already. Please bear in mind there are two people online you can't see, and one of them is representing Colombia, and the other is a Colombian gene bank manager. So yes, Gauta, please.
Thank you, Marco. On mutual supportiveness, because you mentioned the subscription system, right? So and that's the question is basically if subscriptions like the Netflix, right? You know, it's you pay for access, which is the opposite of equity, I guess. So the question is in the sort of expansion of the scope of the treaty, is the subscription model just for the physical genetic resource or also for the DSI? Because if it's for the DSI as well, they might come to odds, right, with the approach that is taken, seem to be taken here, mindful we're not done with negotiating. So yeah, so that's kind of a basic question, because I know the collateral system has been negotiating for a while, and it just started negotiating again. But yeah, so that's the basic question, and how do we case for solve?
That was for you. Yes, and sorry, and just while you're thinking of your reply, I've asked our panelists to put their cameras on so you can see them and think about them when you're formulating questions. So Gustavo and Mathieu and Paolo, if you can put on your cameras, that would help people know who you are. Thank you.
So, the script, I didn't fully understand your comment about the coupling. I think the subscription system actually was initially a proposal from the African group already in the starting phases of the implementation of the treaty to basically deal with the coupling of single access of planet resources. The idea being that you subscribe to a system, a gene pool. You don't subscribe. So basically, a user. There are two mechanisms for accessing material within the multilateral system possible. Basically, the single access mechanism is basically you access one plant genetic material, and there are conditions that trigger that you provide benefit sharing. The case of the subscription system is more holistic. You subscribe to the multilateral system, and you have to basically make a benefit sharing arrangement, which is regular within some parameters in time. Basically, it's not coupled to accessing any concrete sample within the multilateral system. It does allow you to basically access the diversity that's within the system itself. The way the coaches of the working group have structured the proposal right now is that that subscription will capture the use of DSI. But there are a number of legal and policy discussions on how to do that is still are to be confronted in the next month.
Yes, at the back of the room, please.
Thank you. I'm a university researcher from China. I have my research is about global governance of biotechnology. So I'm quite interested in talking about that nowadays the new technology like genome editing or synthetic biotechnology could replace the use of physical genetic resources in agricultural development. My question is, what is the phrase of this kind of application? It's more like a basic research or pilot study by CGR, or it's become already some industrial application, whether it is widely applied, and especially what's the technical barrier, especially for most of developing countries, and how to what extent it can actually replace the past model which based on the genetic resources. Thank you.
You want to take that? It's for your center.
Yeah.
Hmm.
We are not doing this right now. Of course, we have, for example, at CIMIC, we have a genome editing unit. They are working with genetic resources. At some point, I think, yeah, it may replace. Actually, now as a gene bank manager and many other gene bank managers from other centers are also thinking in this digital gene bank view. Yes, we are sending seeds all over the world, but we can also send data all over the world and more easily. So yes, we are thinking also, for example, in having sharing DNA instead of seeds. Because it can be easy for some researchers to just receive the DNA and implement in different with different technologies. For example, we have genotypic information for almost a whole gene bank, but we can, other research can do whole genome sequencing or other technologies. So maybe they don't want a seed, they want DNA, or they just want the data. So there are different opportunities now by using DSI of using genetic resources in different ways. But yes, this is still under discussion and still ideas. But yeah, it's not
It's not yet in place.
Yes, please.
Thank you. My question is in the presentation of IPs and LCs that were part of the IIFP. Indigenous peoples have domesticated some of the most important world food staples, contributing with thousands of varieties of plants, not only for food and medicine, but with responsibilities with the soil, with plant communities, and vast cultural and material systems were built and updated today. So indigenous peoples and local communities became the most strategic partners of conservation. But in the process, and due to the priority and the prospects of commercialization, many more food plant varieties and wild crop relatives in indigenous territories continue going into loss and possible extinction. So my questions to you, and thank you for that very interesting presentation, is how the interest of indigenous peoples and local communities to rebuild their genetic resources and land bases and economic development can also be preserved. How can many of the plant genetic resources they protect when many of the plant genetic resources that they protected have no commercial value for mainstream? Thank you.
I'm wondering, can those of you online hear the question? Not really. I thought there's might be a problem. I'm going to try to paraphrase. Basically, how is it that while we're about this business of developing, I turned it off. While we're going about this business of developing DSI norms at an international level, how can we take into consideration the interests and of indigenous and local peoples to build up their capacity to take advantage of and maintain genetic diversity of crops that are being lost and not being used? Fair enough. Fair enough.
So in terms of the ways in which support to indigenous peoples and local communities is being implemented in the context of the treaty. First of all, the treaty does have an article on farmers' rights, which basically does recognize the contribution that the communities have made to the development of plant diversity, and not only the past development, but that it is a continuous and development. This is a continuous responsibility and contribution. It does spell out a number of measures to realize those rights. There's a very intense negotiation between the parties right now on farmers' rights. So it's really a good moment for indigenous peoples and local communities to be involved in that. So if you want to talk about that after this session, it would be very, very good for me. Then in terms of some of the ways, practical ways that we've been also creating, for us, it's been very important to create interfaces between these two ways of conserving diversity, on farm and in situ and ex situ, and there's a lot of experiences there, including from the CEIR in terms of also being able to restore material back to communities that had lost material maybe in the past and that were conserved in gene banks. So there's a lot of that, trying to build complementarity between the two systems of conservation going on, and also building partnerships between basically communities and plant researchers.
Yeah, I think this may be an instance of what was being discussed earlier this morning in the context of non-monetary benefit sharing, of where there's a lot of sort of decentralized ongoing support for this kind of work by indigenous peoples and local communities from organizations like ours. We've had long-standing programs on community-based natural management, agrobiodiversity management, which involves supporting the creation and maintenance of community gene banks, seed banks, supporting informal, so-called informal or farmer-led seed systems, and conservation of diversity at local levels. The problem is, of course, resources. In fact, the CGIAR is under reform, and we're all bidding for different areas of work. And of course, we're bidding in the center that I happen to be on, and more resources for that kind of work. Whether that comes out in the wash or not is uncertain. And of course, clarion messages coming from bodies such as this saying there needs to be more, and donors should be putting such support on the table and making that measurable goes a long way. So I think, again, coming back to the discussion this morning, there's one thing about money from this fund that we're creating being made available for non-monetary benefit sharing or for community development. But there's also other ways to think about non-monetary benefit sharing that comes from other sources, not from the fund, right? Make an ask in the final decision made by the CBD COP to ask donors to put aside money for community capacity building for indigenous and local peoples, for community-based management. Put it on the table and then have it measurable and have people report against it. It's not impossible. I think we can be creative about that. Yeah. And I know CIMMYT has activities, and I'm sure in Colombia you have activities and experiences to share if you'd like to pick up on this.
You want me?
You can.
Yes, I mean, we have several examples of collaboration with indigenous people and local farmers. To give you few, for example, we have interaction with Guatemala. We restore a lot of, we not call repatriation, we call rematriation, because we give the original accession to them. They lost for natural situation, but we restore this diversity, the local diversity for farmers. We have other issues. For example, in Mexico now, many farmers are getting old, and the new generation are not looking at land races anymore. They look for hybrid maize, or even, they move to the US, no? And they are not taking care of the farm anymore. So we are looking at these issues in different ways. We are trying to bring new generations close to agriculture, show them the value of conserving land races, the value of growing land races, and talking to politicians as well, to recognize the use of land races and the product coming from land races, and give an extra value by selling blue maize tortillas, for example, or different type of products coming from land race conservation. So yeah, there are different activities that we are doing. I can comment a few more, but yeah, I think I stop here.
We've run pretty much to the end of our time. I'd like to give our panelists online a chance to respond or to add anything that they would like to do to add in light of the questions and answers you may have or may not have heard, and I apologize for that. But I'd like to give you a chance to conclude for us, if you would. Yeah. Well, if you won't, I will. Okay, it's 3 o'clock and it's time for everyone to go to the contact groups. So good luck. And remember everything you learned here. Take it with you to the contact group on triggers. We can measure our impact thereafter. Thank you very much for coming. Thank you. I hope you can hear. We're wrapping up. Thank you so much. We'll have a recording and we can share it with you later. All right. Thanks so much. And I apologize for the technical difficulties.
Thank you. Okay. Bye.
Bye.
Thank you.